Okay, so here's the first question. It says ABCD is a cyclic quadrilateral, and we know that because all the four corners touches the circle circumference. With the center O, notice that this line across here is not a diameter, it does not go through the center. Angle XAB is 58 degrees, angle BAD is 34 degrees, and angle DBC and DBC is 34 degrees. That's this one. And BAD, XAB is 58, BAD is 78. Okay, so all that information is sort of given in words and on the diagram. Prove that AB is parallel to CD. So we've got to prove that AB, this line here, is parallel to CD. Now, we can't assume that they're parallel. We've got to prove that they're parallel. Now, a characteristic of parallel lines is that these angles here, which are called alternate angles, you may know them as sort of Z angles, if you like. So they sort of form this sort of Z shape. You shouldn't remember them as Z angles. You should remember them as alternate angles. If they're truly parallel, then this angle here and this angle here will be equal. So that's what we've got to show, really. Now, one of the first things that you should notice is in this question, we have chords meeting tangents. Okay, there's a chord here, it meets the tangent. There's a chord here, it meets a tangent. And one of the things that we know about chords meeting tangents is the circle, is the alternate segment theorem. And the alternate segment theorem says that when a chord, so if I draw this, when a chord meets a tangent, then the chord subtends an angle, which is this angle, which is equal to the one in the opposite segment. So that means that this angle 58 degrees here is the same as this angle here, 58. Okay? We can also work out this angle. So this one is, so we can say here, let's just do BDA is 58 degrees. Alternate segment theorem. Alternate segment theorem. We can work out this one here. This is, because of angles on a straight line, this is DAY is equal to 180 minus the sum of the 58 plus the 78. And if we do that, 58 plus 78 is 120, 136, leaving this as 44 degrees. So this is 44 degrees here. Now, we can use the alternate segment theorem again now. So let's just remind ourselves, when a chord meets a tangent, the chord subtends an angle, this one, which is equal to the one in the alternate segment. So that's 44. So we also know that this is 44. This is from the alternate segment theorem again. Now, if that's 44, we can't just assume that this is 44 straight away, because that's cheating, because we don't know for certain that they're parallel. We're trying to prove that they're parallel. But what we do know is that we've got a cyclic quadrilateral, and we know that the opposite angles add up to 180 degrees. Okay, so we can now use that fact. So since opposite angles in a cyclic quadrilateral add to 180 degrees, we can say that this 34 plus 44, so that's that big angle there, is equal to, let's call this x, 58 plus x, plus all those added together is equal to 180. Opposite angles in a cyclic quadrilateral add to 180. And if we work out, what we get here now. So let's add the 58 and the 44 and the 34 together. So we get 6K156, we get 136 here. So we've got x plus 136 is 180, and then we subtract 126 from both sides, and we get 44 degrees. So that means that x here is 44 degrees, which is really what we wanted, so that we do get these alternate angles. So hence, since we have alternate angles, we have parallel lines, and we have AB parallel to CD. It's quite a tough question to start with. It just happens to be the way they're ordered.